Good morning, good afternoon, good evening, and welcome to the Level Up Hour here on Red Hat Live Streaming. I am Chris Short, host and showrunner of Red Hat Live Streaming. As you can see, the usual suspect, Langdon, is missing. We wish Langdon the best of luck. He has taken on his professorship duties at Boston University starting this week. And if you weren't here last week, Langdon is no longer at Red Hat. So, just to let you know, he is off to being a professor. So me calling him illustrious and a professor on the show might have done him some good. I don't know. Maybe. I'll take credit for it, though. So today I'm joined by the new usual suspects, the one and only Randy Russell, Jafar Charabi, and then we have special guest Eric Nelson here. Let's just go around the horn real quick. Let's do some intros. You know, Randy, I'll toss it over to you as the quote new host of the show. What do you have to say for yourself?
Hello everybody. I'm Randy Russell. I'm the director of certification at Red Hat, and really excited to be joining the Level Up Hour and having these discussions with you approximately every week ish.
Yeah, you know, when we're not dark for various reasons. Jafar.
Hey everyone, so my name is Jafar. I work as a tech marketing manager for OpenShift, and I'm really glad to be here. I'm trying to grow my beard, so it looks like a bit like Langdon, but it's gonna take a while. So
yeah.
So hopefully in 40 episodes it might be good.
Keep it up. You got a little ways to go there.
Eric's almost there. I will say. Scott McBrien is also going to be on the show regularly, but he is off this week. So he's on PTO. We're going to talk about Konveyor today, and specifically the Crane project.
Where's mine?
Where's yours?
Yeah.
I'm sorry.
Oh, I can definitely get you one.
Oh, there you go. Have at it.
Have an in.
They are $6, I think, on the Cool Stuff store for what it's worth. So yeah, Eric, you're here.
Hi, hello.
How are you? Welcome back to the channel.
Thanks for having me. I am Eric Nelson. I'm a manager an engineering manager in migration engineering. So I work on a project called Crane, which is the topic of this conversation. Downstream, it's known as Migration Toolkit for containers. I've been an engineer at Red Hat for 5 years at this point. And prior to that, I'm a computer engineer, and actually I went to school at Boston University, so I know that's a pretty good program.
Yeah, there you go.
Yeah.
See, if only you delayed your education, you could be learning from Langdon.
I should have done that.
Yeah, you could have been taught by the illustrious one, but oh well. Go back for your master's or something.
Yeah. I'm in Raleigh now, so but I do miss Boston quite a bit.
It's gonna be AI-based migration.
There you go.
Exactly.
So just to let folks know, we will still, at least for the very short term, have our usual points and everything else. Langdon has handed all that off to me. The sweet internet points are here still. As far as their value, that is up in the air still. Sorry, I haven't heard anything otherwise. But I know that something is coming, so we'll keep the points going for now. So we're talking about Crane, migrating container workloads with Crane. So I already got a question fielded for you, Eric.
Shoot.
But let's go ahead and talk about what Crane is first before we dive into the question that I have.
Sure. So Crane is should I show the slide that kind of gives an overview of Konveyor in general?
Yes.
Why not?
Yeah.
Maybe before we even dive into Crane, let's talk about Konveyor.
Konveyor, yes. Thank you, Randy. I know.
Can everybody see this diagram here?
Yeah.
Okay. Cool.
Absolutely.
So Konveyor is I think there have been some other projects from the Konveyor org that have been here.
Yes.
So folks may have heard about it, but I'll just quickly give an overview. So Konveyor is kind of an umbrella like collective of projects that all sort of have a shared objective to just move people to cloud native environments, specifically Kubernetes. and so that can be like there's a lot of paths there. There's a lot of problems that are involved. So there's a lot of projects that seek to solve a bunch of different problems. So you can see here there's rehosting. So maybe you've got like one cluster in one place, you want to move it around. Crane concerns itself with container workloads. So like traditional Kubernetes migrations, maybe you want to go from one cluster to another and it's already been containerized. Then there's a project called Forklift, which concerns itself with actually picking up VMs and moving them to Kubernetes clusters, which is pretty cool. It uses KubeVirt. So it's kind of Forklift and Crane are kind of sister projects in that respect. Then you've got replatform. So move to Kube expects a source that's not a Kubernetes cluster. So other platforms such as like Docker Swarm or Cloud Foundry, this will pick stuff up, kind of analyze it, spit out Kubernetes objects, and then that'll help you get like sort of convert your workloads to Kubernetes. Tackle, I think, was the one that was actually on here, if I'm correct. But this will help you actually refactor your applications. And I think we'll probably talk a little bit about this, but all applications are not just created cloud native out of the box. There's a lot that actually goes into architecting and designing and writing like software so that it expects to be running inside of a cloud environment and that it can take advantage of all the benefits that are associated with that. So Tackle helps you actually look at your application and make some recommendations about how you can manipulate that. And so that's turning into Migration Toolkit for applications, which is our supported downstream offering. You'll hear me say like MTC or MTV or MTA. All of those are like our downstream references. And then we've got our upstream projects. And we're trying to move towards this like upstream first model.
Let's go easy on the acronyms because
yeah, for sure.
I get
confused.
Business of names. Did the move to Kube people not get the memo
right
on the naming conventions? Because I love Crane and Forklift and Tackle because they are in fact very descriptive of what these things do. Move to Kube also descriptive, but that's not from the moving industry. It's not for the building industry. Come on, you know?
Yeah, it's well, we know that like in software, the hardest thing is like actually naming things. So
yeah.
But actually Move to Kube is an IBM project. So it started with IBM. So that's actually the background there and why it hasn't adopted one of those types of names.
Okay, fair enough.
And then finally, there is Polaris. So this is like sort of metrics, like measuring the changes and impact of like how you've delivered things. And it's almost in order of like maturity. Crane's been around since 2019. So I guess I can jump into Crane. Any questions about like Konveyor in general or what we're doing here?
Well, let me just throw a really high level question out there on this. And so this project got kicked off really earlier this year, right?
Crane or Konveyor?
Konveyor.
I think it's been around maybe, let's say, a year and a half.
Okay.
Crane did predate Konveyor as an organization, but it's true that it's been around for, let's say, under 2 years.
Okay. Yeah. So we have some of these independent projects that have sort of come under the Konveyor umbrella as all being related in the sense of being able to manage this big picture, right? In different ways, whether it's replatforming, rehosting, refactoring, there's a tool for everything, right? So here's the thing I kind of wonder as just sort of first high level question is, you know, we have this need right now to have this sort of tooling. Do we anticipate that this is the sort of that the Konveyor project and that these things under that Konveyor umbrella will continue for years to come because this is going to be an ongoing need? Because I think of Polaris as sort of the end of the cycle, but it takes you right back to the beginning of the cycle.
Yeah, for sure. There is an expectation that this is going to live on, and it's not just migrations. Like migrations are sort of like a point in time event, and once you're there, you sort of. But you know, we've learned that that's not really true. Like you pointed out, Polaris is something that you're going to use to for day two operations, monitoring things, upgrades, all that sort of stuff. And then Crane, the genesis of like Crane was to move people from OpenShift 3 to 4 because we didn't have a migration path there. But it quickly became apparent that I can get into this, but you know, in order to take advantage of hybrid cloud, right? Like on premises and like cloud environments where you have burstable resources and stuff like that, your applications have to be architected to be portable. And not only that, like there's a whole environment around them where they need to live. Like they need to be decoupled from the environments that they live inside of and exist in kind of a golden source location. You could call this a Git location, a Git repository that deploys them out. So in an environment agnostic way, so you can like point it at a cluster and kind of deploy it there. So in that respect, it's an ongoing problem. And especially when you consider hybrid cloud where things are moving around, you need things to be fluid. And so a lot of these projects seek to help you do that. And maybe your source code isn't
hybrid without portability.
100%. And portable apps is an ongoing concern. So it's not a single point in time migration. So a lot of these projects underneath Konveyor are seeking to help that. And in addition to that, Konveyor is kind of a living, breathing thing. It's not just a set of repositories. We also are running like meetups. There's conversations going on mailing lists. So it's a community, really, is a more accurate way to describe that. And again, like that's anybody who's interested in this is a great place to kind of connect with other people who are also interested in the problem and work on tools that will help you achieve that.
Great.
Awesome.
So do we want to talk a little bit, drill into the wonders of Crane?
Yeah,
Sure.
I'll save my questions for a bit later when we have a better understanding of what it does.
Mm-hmm.
Okay.
But I already have a few questions.
So I'll go back a little bit. So I mentioned that like Crane is the upstream name. At the time, it was really only MTC, which is Migration Toolkit for containers.
Mm-hmm.
I'm just going to call it Crane. We'll call it Crane V1 because there is a Crane V2 that's on the horizon. And that's kind of the interesting part of like what I was hoping to discuss here. Crane V1 concerns itself with like mass cluster evacuations. So this is something that a cluster administrator, and that's an important point. It is only available to cluster administrators to pick up everything that's in a cluster and move it over to a second cluster. So this is a total, like a whole migration. It does not concern itself with the control plane. So it operates at the application workload layer. And primarily, usually when you think about a Kubernetes migration, it's kind of three buckets. You've got the Kubernetes resources that make up the application. So you're like pods, deployments, stuff like that. Your images that back the containers. So often these are images that are living inside of like a registry that you've either got inside of the cluster, somewhere else maybe. And then finally, there's the state, which is kind of the hard part. Exactly.
Yeah.
That lives inside of the PVs. So Crane picks all that up and it moves it over in a specific manner. I can get into like the architecture of how it's architected, but yeah, that's the objective, and it will do it at like a sort of a mass scale. So we've had, I mentioned in kind of the show description, we've done like large scale migrations, and I would call those like we're talking multiple clusters and many geos with thousands of namespaces. Crane operates at a namespace level, so that's the like unit of it's the atomic unit that we use in order to migrate things. Often people will organize their applications within namespaces on a namespace basis. That's not always the case. So you could have like microservices that have interdependencies spread across namespaces. In which case you're going to want to evaluate that and make sure that you bring them all over together as part of a plan. But at a high level, it's effectively it's an operator backed application that is controller based, and its API is composed of CRDs. So it's using the Kubernetes extensions as its core API. So you can communicate with it as you would any other kube object. And so it uses that sort of declarative reconciliation pattern that Kubernetes is famous for to execute these migrations across clusters.
Nice.
Yeah.
So we already have a question in chat, which was the question I got before the show even started. Go ahead, Jafar.
No, go ahead.
You sure? Okay, fine.
Yeah.
And J.W. Matthews just answered it in chat. But air-gapped environments. Talk to me about that. Can we use Crane?
Yes.
Like, tell me more, because
we have a
question today.
It's a primary concern for a lot of customers. Of course, they don't have these things just living out on the internet. They're pretty important, and they live within disconnected environments. So there are a couple levels of disconnected that you can kind of think of. Air gapped would be one, which is like, this is 100% not accessible, which is possible. And then separately, you've got a pseudo disconnected, which is sort of, it has limited external connectivity. Maybe it can see the outside world through a proxy or something to that effect. Both of those are supported. And we've had a lot of people use MTC in that manner. So the way that works is with OpenShift 4, OpenShift 4 uses OLM, which is kind of its packet operator repository, right? And there are mechanisms that allow you to mirror the images into the environments so that you can actually deploy MTC. In order to actually perform the migration, we of course do have the requirement that both of those clusters can see one another, or at a bare minimum. Well, there's also, this is getting into kind of how MTCs are architected. Underneath the covers, MTC uses a project called Valero. Some folks may have heard about that.
I've heard of it. Yeah.
It is a backup and recovery solution for Kubernetes. The world's kind of coalescing on it as like the backup and recovery solution, DR solution for native Kubernetes. So we're built on top of that. So actually MTC, what it is a controller that orchestrates a migration using a series of backups and recoveries, communicating with Valero, which kind of executes underneath the covers. This has changed over time, but that's kind of the crux of it. For that reason, we actually require an intermediary repository where we back things up to, and then we recover things out of. So we recommend for a disconnected and air gapped scenario to actually deploy. You can run like OCS, which is our container storage solution, on an OpenShift 4 cluster. And there you can set up your S3 repository that's self-hosted. So it's all on your, let's call it your target cluster. And you'd be able to use that as your intermediary repository. So the controller would basically move all your data out of the source into that target repository, and then it would recover from that repository into the target cluster. Trying to think what else is relevant as far as disconnected.
Is the operator and the certified index or their operator index?
Yes.
Up. Okay, that's what I figured.
Yep, MTC, you'll find Migration Toolkit for containers there. And then there's also a community operator called Crane.
Yep, awesome, wonderful.
So I do have a question, Eric,
Sure.
which is related to what. So I kind of like the way you dissected the main areas of interest when you're doing this kind of migrations. You spoke about like the resources, the Kubernetes resources, which are basically like the whole YAML files you have to export in order to be able to push them somewhere else. You have the data, and then you have the images. And so I know that we started this project a while ago, like 2 years ago, when we started addressing the migration from 3 to 4. And at that point in time, GitOps was not yet like a very hot topic.
Mm-hmm.
So the whole thing was, I had customers asking me while I was still, doing pre-sale stuff, like, so what's the proper way to export stuff like my resources and get rid of all the cluster specific details like creation date, IDs and stuff like that in order to be, to make them generic and then push them somewhere else. So that was sort of a manual process. And I think that MTC at that point in time already was able to solve that kind of questions by introspecting the cluster and being able to migrate items without necessarily having the definitions at hand. But so my question now is, now that we are also playing in the GitOps field where we have this notion of, now that I have my resources descriptors, like all my YAML files stored somewhere, I can push them across multiple clusters, and I can also keep that consistency. Like if I update something from the source cluster, then I can automatically maybe, update it and mirror it back to the remaining clusters. So is it something that MTC is working with? Is it something that, so how does it, like, because the way I see it is you have the operator that does this thing, it introspects stuff and it moves resources somewhere else. But does it make sense to sort of plug it, GitOps, I would say, engine somewhere inside MTC to have that, that reconciliation loop capability and all of those, new stuff that came up recently, I would say.
Yeah, 100%. I'm happy that you're kind of teeing up perfectly what Crane 2 seeks to do.
Okay.
So MTC1.
And I didn't know that.
That was
the beauty of it.
apt. I mean, it's interesting because you're pointing out like a real pain, right? Like this is what people want to be doing. And so we've spent a lot of time talking with services folks and people in the field and customers trying to figure out like what are the things that you want to be doing, and how is MTC was a little bit early, believe it or not. Like it sort of missed like there were still a lot of like people sort of figuring this space out a little bit when we did a lot of the initial design, but we still believe that there is space for MTC and Crane 2, and I can get into Crane 2's objectives. They're targeting two different problem spaces. The first one with MTC, this is sort of its some of its faults are sort of also core to its design. It's a tool that does a mass cluster migration. So, and it's a tool for cluster administrators. So they can pick up a whole cluster, pick up all the app workloads and move them over to a target cluster. What we found while while seeing this actually in production migrations is that oftentimes cluster administrators have no idea what's actually inside of their namespaces. So imagine there's a large university, right, that has all of their students running their WordPress blogs inside of namespaces. Some of them are crashing, like the whole cluster is kind of a disaster. They don't really know what's inside of those. They don't know if a crash loop pod is a problem. They don't know that like the interdependencies between namespaces, the application owners do, and the developers do. They're the people who are deploying into these environments. So that was the first thing, is that the fact that MTC is a cluster admin required tool, in addition to the fact that the admins kind of don't know what's inside of those namespaces, means that there's kind of a gap that needs to be filled. And that's where Crane 2 comes in. So the app owners are really the people who understand their applications and their interdependencies and everything about that. Let's like shift that paradigm a little bit and have the developer, the app owners themselves actually migrate their own applications. So that distributes the load of and the burden of a full cluster evacuation. It also allows you to do it in piecemeal, which MTC can do depending on how you slice it up. But so that's one of the first objectives of Crane 2, is to actually allow for app owners themselves to migrate their applications. The second thing is, you're right, like you kind of nailed a lot of the points that Crane 2 is thinking about. I like to kind of describe hybrid cloud, like Crane 2 allows you to unlock hybrid cloud, because there are a lot of these applications that are like snowflake applications in that they're very tightly coupled to the environments that they live in. They've probably had like kind of duct tape, like changes made to their resources over time that are specific to the environment. We know of a lot of examples of that. Let's call them node selectors, resource quotas, like stuff that you pointed out. So in order to actually access hybrid cloud, first you need a portable application. And what that means is you need to strip out a lot of that like cluster specific information. And then you need to version it. You need to put it into GitOps model. It actually could be like kind of any real versioned. The point is to version it in a cluster agnostic way. And then and then continuously deliver it to your various clusters. And maybe you want to actually layer on some more cluster specifics as you do that. So that's starting to sound kind of like a pipeline, right? And so what we're interested in is with Crane 2 is actually building that pipeline where you have that discovery aspect where even app owners may not know what's inside of their namespaces. So it goes out, it exports all of the stuff that's inside of the namespace. And then it applies some transforms to those objects that are, by the way, commonly, like a lot of people are going to have common interests. Let's say they want to strip the status, which is not actually relevant for a target cluster, for example. And also it's not a live application, so it doesn't necessarily have status at that point in time. So you want to strip that stuff out. Maybe you want to there's another example with routers, like maybe you want to strip out the host that it lives behind, because of course that's cluster specific. And then from there, once you've applied these transforms, and we have a plugin model around this that's I think is pretty exciting, that allows like services folks with shared problems to build their own plugins that are reusable. You can pull them off the shelf and apply them. And then so you'll get this kind of like stripped down portable representation of your workload that can be versioned. So you check that into a Git ops, a Git repository. You flip on your Git ops, and then you can use this pipeline to deploy it out into whatever clusters that you're interested in deploying it in. So Crane 2 is designed for that. And in a lot of ways, like, it's a migration tool, and it allows you to migrate from an application to cluster. But really, while you're doing that migration, it's a great opportunity to modernize it too, and to unlock that hybrid cloud by adopting that GitOps model. And so we want to help people get to there as well. There's a lot of unsolved problems there. State is one that's tricky. And there's a lot of conversation that's happening that we're involved in some of the upstream kind of like SIG groups, data protection, stuff like that, where how do you like fluidly replicate your state across a cluster? How do you deal with the fact that these applications are live? So maybe you need to quiesce the applications, move them into a read-only mode so that you're not corrupting your data while you're moving it around. Stuff like that are tricky problems to solve. But that's really what Crane 2 is seeking to solve, is and how it differentiates itself from MTC. Whereas MTC will continue to live on as this like mass cluster evacuation tool, and Crane 2 seeks to be kind of that tool that's designed for app owners to export, transform, and modernize kind of their applications into a GitOps flow so that they can be then redeployed in a cluster agnostic way. Beautiful.
So yeah, thanks a lot for this like very comprehensive answer, and I'm happy to see that you know, it's sort of it's going to solve some of the questions that I saw within the field. So that's cool to see that we are, you know, addressing those real problems. So I have another question if nobody wants to step in.
We have some questions in chat, but go ahead.
Okay, yeah. So you mentioned one key aspect, I believe, is the understanding of the application and its ecosystem, like its dependencies. And when we mean dependencies, it can be things like the data it's relying on, like databases. So you can have a pod running in certain namespace, but if you don't migrate a database that runs in another namespace or another microservice or something like that, the application is not going to be fully, I would say, working. So I was doing for a few years some enterprise architecture consultancy, and one of the key things that we did before, you know, when we wanted to address these types of migration, was assessing the application and like properly having an application topology where we model the application and its dependencies, like in enterprise modeling solutions. So without going into that much of advanced stuff, do you guys think, I haven't seen MTC recently, but is there a way to sort of gather the dependencies of a specific application? So you said, for instance, the admin doesn't know the application, it doesn't know to what services it needs to talk, etc. So I believe it would be very helpful when you look at an application definition within those tools to have something that says, here's the application and here are all the services that it relies on. Like it can really point to some specific namespaces, services, etc. Do you have something like that that like gathers objects from the existing cluster to give an overview or a topology of the application and its dependencies? Or even if we can, you know, just describe it by text or something like that. Is it something that you have, that you plan to have? What's the take on that?
It's definitely important. And MTC doesn't do that. And neither does Crane. And it's kind of a gap in Kubernetes in general. Kubernetes doesn't have a high level abstraction that kind of encapsulates like, this is my application and all of its interdependencies, which is a gap. And I know that there are conversations. There's a lot of conversations that are going on around that.
In the SIG apps, I think they're trying to address that.
100%. And that's what we would build our migration based on, instead of like the unit of migration. And like the closest we can get to that is kind of a namespace out of the box.
Yeah,
the problem, everybody kind of represents them in different ways.
Yeah, because sometimes you can have several components living in different namespaces for the same application.
100%.
And that's where, you know, it becomes harder to get the whole application, which relies in like 10 namespaces or even 5 namespaces or whatever.
Yeah, our recommendation is we kind of expect that legwork to have been done. It is a problem that I think there's opportunity to solve and make that easier for sure. I think that I've heard some like rumors of other tools that may seek to do that. But it seems like it would be an opportunity and a perfect problem to kind of be explored underneath the Konveyor umbrella. We also have mechanisms for actually onboarding new projects, stuff like that. But yeah, MTC and Crane don't concern themselves with that sort of analysis.
Cool.
All right.
Good to know. All right.
Okay,
Randy, do
thanks.
you want to tackle these questions in chat, or do you want me to handle it?
Please be my guest.
Okay. What if I want to migrate my OCP cluster from one data center to another? Just because I heard the word Valero, is this covered by these Konveyor tools?
Yes. So if you have an OCP cluster in one data center, you've got another one. That's like the bread and butter of what MTC does. So you just to quickly describe kind of the data model and how you would do that. You have to install MTC on one of your clusters. And actually, it doesn't have to be the source or the destination. It could just be a third cluster. In fact, like I've seen people run it on their laptop and like one of the developer clusters and connect out. But so you install it somewhere. And then we've got this CRD data model that represents everything that we need. That's our API. And so you can communicate that with, so we have a UI that can be used, and that's super helpful. It's gotten very, very useful as we've moved forwards. It's particularly useful when things go wrong. And as we've learned with migrations, these almost never go smoothly. So it's very helpful to have. So you register the clusters that are involved in your migration. So you'd register the 2 clusters. You give us like the coordinates to the cluster as well as your credentials so we can access it. Then you're going to go set up your replication repository, which is this intermediary storage where we're going to export and import our data to and from between the 2 clusters. And then you're going to draft a plan. And what that means is you're going to pick the namespaces that in your source cluster. You're going to pick the PVs and how you want to handle them. Maybe you want to change your storage classes. You're converting from like cluster to Ceph or something like that. And then there's a few more details, but at its core, the MIG plan represents this is what I want to move. And there's a discovery process that helps you figure out what's available to you to move. Next up, and the way that we've built MTC, this is getting into a lot of people want to reduce their downtime as much as possible, of course. So some of these applications can be quite heavy. We've done terabyte volumes before. So what you're going to want to do is stage as much of that data as possible. This is assuming a stateful migration, of course. Stateless is a lot easier where you don't have to deal with this. So you can leave your source application up and running. You'll stage as much of your data as possible onto the target without taking your application down. So let's say you get like 99% of your data onto the target. And then you do your final cutover migration, which quiesces the source application. By default, you can actually switch that off. And then we'll grab that final delta of data that's been written between the last time that you staged your data and currently. So we'll get that last piece, we'll move it over. And by staging all of that data, the time that it takes for your final cutover and your downtime should only happen during the time that we need to capture that final bit. I think that's it. Yeah, that's MTC in a nutshell. So that's going to help. That's how you can migrate from one data center to another. Of course, there are these like caveats where both of them actually need to see each other. They need to have access to a replication repository. But that's how that works.
So I do have another question.
Go for it, Jafar.
Yeah, related to what you just talked about. So when we're speaking about the state of the applications, as you mentioned, one of the problems is to get that live data. So it's easy to migrate static data that doesn't change. But if you want to get the last updates to the data while you are already planning or doing the migration, it gets a little trickier. And one of the things that happened in that space, in the data migration or synchronization, is what we call CDC, like change data capture, where you have tools that are able to plug onto a source database, where you say, so here's my e-commerce database, and here's my target database, and it does actually migrate and copy the data, but as soon as you have a change that occurs in the source data, it also replicates it into the destination database. And so I know that Red Hat has an upstream project about that called Divisium. Are there any plans to sort of try to plug into tools like that could help address that issue of capturing data, but also keeping that update easier, or in a more I would say industrial way with Crane? Will it make sense to have something like that plugged in and help synchronize the data?
I actually haven't heard of that project. I'd be interested to look at it a little bit. We don't have there's no plans on the roadmap currently to integrate with a tool that helps you do that. I actually don't feel like we haven't had a ton of interest in or problems that have been raised around active applications that are writing during a migration or something like that. However, we do have concepts that will help you do that. We have something called a hook so our migration is broken down into an itinerary of steps. And in reality, it's a state machine behind the scenes. So what you can actually do is write arbitrary logic into hooks during the migration. So let's say like pre-quiesce of the application, you'd be able to, so we'll delegate out to the user. It's hard to write like a fully generic migration tool that's going to satisfy everybody's needs. So as part of that, we want to develop a hook mechanism so that you can hook into that process and do some custom work. I've seen people use it for things like DNS, like changes during a migration at a specific time. That might be an opportunity to use it. So maybe you want to hook in and do some intelligent operations with like you can take advantage of some data APIs that are available to you to switch things on so that you can replicate it across clusters, stuff like that. So you can hook in, and the way that it's implemented actually is out of the box. It uses Ansible, but actually it's just we run an image and we'll provide it kind of there's like an entry point. Yeah, there's a contract, so you can rely on, like, you'll get some specific information about the migration that's going on, and it's just using an entry point, so it doesn't actually have to be Ansible. So you can provide us a playbook. We can do Ansible, or you can provide us just an entry point, and then it can be anything that you want. So you can execute some arbitrary logic. So that means maybe you're communicating with external systems or something like that to trigger like some type of replication during the migration. There isn't that like ongoing data sync post migration, but there's a lot of investigation that's going on. We have folks in some of the SIG groups that are looking at data movers and volume replicators, stuff like that are lower level Kubernetes concepts that I think seek to achieve similar ideas, where you're sort of like propagating data across and changes across multiple clusters in PVs. And there's also like, I think some of the storage providers will actually provide that as well. I think like we have a so it's actually outside of outside of Kubernetes in general, it's able to propagate data across, so that like two cluster like storage layers will be synced and look similar.
So speaking of like storage layers and things like that, if we're using something like Open Data Foundations, formerly known as Open Container Storage or OpenShift Container Storage, how do we migrate? How does Crane migrate those PVCs? Is it still using Valero at that point, or is there something that we're leaning on in the ODF space?
We have a few different mechanisms. I'm picturing a slide that we have that's floating around that's kind of like a pyramid. There are a bunch of options that are available to you, and like you're going to choose one depending on what makes the most sense for like the storage that you're using. So there's two ways that you can actually move your data. I'm struggling. I don't want to call it move because that's one of the ways is a move versus a copy.
Right.
So I think something like 70% of people are using actually just NFS. So with NFS, it's interesting because like if you've got a ton of data, like a terabyte volume, copying that data is going to take a very long time, obviously. Yeah. So one of the better approaches there is like, oh, I've got shared storage and both of my clusters can see this shared storage. Why don't we just pick up one of those volumes and plug it into the destination? So that's called a move. And that's going to be your fastest way to get your data and make it accessible in the target if you're using something like NFS. Of course, there are caveats there where that is the data, that's the golden source. So you're not cloning it, which means you need to be careful. And there are implications for rollback and stuff like that when you're actually picking up your data. Of course, backup, all like healthy backup practices apply here. And then separately, there's a layer below that where depending on your storage provider, let's say you're using Amazon, I'm blanking on the name of their storage. Yeah,
S3,
EBS,
whatever.
Exactly.
They have a few.
So most of them have snapshot APIs. CSI is one of the formats that everybody's talking about, and Crane 2 is interested in. So we can actually create a snapshot and recover from a snapshot on the target side. So that operates at a different level than the file system. And then one layer down from that is actually like a file system level copy. So we had a couple ways of doing that. In the initial versions of MTC, we used a project called Restic indirectly, which is what Valero actually uses.
Yeah.
So it would copy data into the replication repository, and out of it, I understand that it was similar to an rsync mechanism. I think it had incremental backups functionality. We had some limitations with that. We ran into some limitations. And so we actually optimized that with some of our recent MTC releases where we offer a direct data migration. So now we offer direct volume migration and direct image migration, which means you can skip that intermediary replication repository and we'll actually rsync the data using like an S-tunnel mechanism directly into your target cluster. So in theory, that should cut your migration time in half for that. And that's something that we developed in-house. So that's our solution. And actually, I have an interesting story about that too. As of our most recent release, where this is moving towards the Crane 2 world, where we kind of learned a lot and have codified that knowledge into a library called CraneLib. And so we're moving some of that logic out of MTC into reusable libraries. And then we're refactoring it and bringing it back into MTC. So MTC now depends on CraneLib. The interesting part about that is now Crane 2's CLI is able to actually use the same mechanism. And so we're developing all of that in one core place. There's also another project known as Scribe that's connected to Red Hat and that we're interested in contributing to because it's also solving a lot of similar problems. And of course, this is like kind of the open source way. Let's combine forces and start to do our development upstream. So we've moved a lot of that knowledge and logic into CraneLib, and we're interested in contributing that into Scribe as well.
Nice. Cool. So lots of work is what I hear. Lots of work is being considered around state here. Good. And thank you.
So I had a question that if I go way back, you were talking about Crane 2 and some of the design goals and things that you were looking at doing there. And, if you think about Crane 1, it's pretty much sort of seen as a one-shot deal, right? And it's, let's get you through that migration. Now I'm simplifying, but with Crane 2, it sounded like you're also guiding the application owner towards some practices that will be better in the future. Did I understand that correctly?
Absolutely. That's the goal, right? Is let's while you're doing this, it's almost like we try to avoid saying this, but it's almost like an anti-pattern to just pick up something and put it into the destination, right? Because you're carrying with you all of that cruft and that legacy just weight that's associated with this like environment specific application that's just not truly cloud native in the sense that it's like fluid and portable. So we have the opinion that GitOps is sort of the solution towards that, and so that's one of the goals with Crane 2 is to also help you adopt and help customers adopt the best practices, because there's a lot of people who are not doing that, and so when you're using those best practices, it unlocks a lot of things that are become available to you, like hybrid cloud and all the benefits that are associated with it. So that's one of the goals, is to help people migrate to, like, not only migrate their application, which is their core interest, but also leave you in a better place than when you started.
Nice. Right. Yeah. Well, so, to make a metaphor of it, I think about moving one's home. And you know what? If you have a bunch of cruft in your attic, that first move that you make, you'll go, wow, I don't ever want to do that again. And then you discover that there's other things along the way that you think, well, okay, if only somebody had told me that getting a storage unit, that I could take the stuff and stage it there before actually moving it to the home that would not be ready, or until the moving day. That's kind of what I'm hearing about Crane 2, is that it does start guiding some practices towards what will, from experience, right? Here's what has been a challenge in the past. These are the hurdles that we have encountered. Let's just kind of set you up so that the next time you're having to do a migration, you are going to have a much more painless one. Is that about right?
Yes. That's it. I love that metaphor, because it's actually really apt. Like when you're doing it, you sort of like acquire all of this junk, and then and that's your source application. But when you do that move, it's an opportunity to kind of get rid of all of that and make yourself a lot more fluid and able to move again in the future without all of that burden. So that's a great analogy. And then on top of that, it's almost like you remove the necessity for migrations at all, because you've moved yourself into an environment where you are portable enough, where it's like, it reminds me of when Git started to become popular. It was like, for a long time, branching was a very expensive operation. It was not something that was to be taken lightly. Git just said, hey, why just branch early and often? And it sort of changed a lot of those patterns, and we're better for it. And so, it's almost like moving into this GitOps world. It's just like I'm redeploying into different environments and hybrid cloud. That's just a matter of course. That's a normal day-to-day thing. And so you remove the problem entirely, because you're fluid enough and you're designed to take advantage of hybrid cloud.
Yeah, well, so I think that's the difference, the difference between being cloud native versus hybrid cloud native. In a hybrid cloud native world, the notion of migration starts to actually disappear a little bit, because you've already built things in a way that you're not tackling it as a migration. It simply just comes with the way you've actually architected the app in the first place.
Mm-hmm. Yeah, you're basically just instantiating new apps somewhere. So I do have a question regarding that. The notion of hybrid cloud approach. So one of the things I liked with the KubeVirt and OpenShift virtualization is the ability to have a hybrid application that is composed of containers and of virtual images, within the same app. So I was wondering what the approach would be, or what are the plans for that type of applications. So say I have a containerized app that talks to a VM that lives outside of Kubernetes for the moment, but I do want to migrate them. So as of today, I understand that I have to use the two separate tools. Like I have to use MTC for the container part, and I have to use MTV for the VM. And at some point, they're going to land, maybe they can land in the same cluster. So I have two questions. So the first one, would the correct way of doing it today, like first migrating the VM from outside Kubernetes to the source cluster within the same like namespace of the application or something, and then migrate the two together with NTC. So the question then is NTC able to understand a CRD like virtual machine, or is it just like plain CRDs that Kubernetes understands by default? So that's the first part of the question. And the second one is like, if we think a little ahead, are there plans to have like an umbrella UI that allows you to combine both? Like I have a container coming from this and I have a VM coming from this, and they do migrate as a single entity in a target namespace or something like that, although they both come from two different tools.
Yeah, I think in that scenario, I actually have not had any, I don't know of anybody who's actually tried to use MTC and MTV, which is the container and the vert tools in conjunction with one another, Crane and Forklift. I haven't seen it done, and I haven't seen actually really any, I haven't had interest come across my desk, so to speak. But I think that doesn't mean that they can't be used in conjunction with one another. MTC does understand CRDs, and actually it will crawl and discover like CRs, instances of the CRDs, and actually migrate the CRDs themselves, which is interesting because CRDs are actually cluster scoped. Right. And it does handle some cluster scoped resources when it recognizes that there's a dependency that's necessary.
Like the operator, it can go back to the operator to have the CRDs.
Yeah. Operated workloads are actually an interesting problem that MTC in some cases has difficulty with, because there's sort of an interesting, this is a bit of a side tangent, but like do you migrate the CR that the operator is actually operating on and delegate to the operator to reconstruct the application on the target side? That's actually probably the correct way to do it. And then Helm is another whole thing. So I can get into that, but to come back to your question, I would recommend in that scenario, I think Crane 2 in conjunction with MTV would be an interesting option for you. Crane 2 is particularly, I sort of touched on this a little bit, but like we built Crane 2 to be a collection of tools, and we like to call it like just kind of, it's the classic Unix philosophy, right?
Unix toolbox.
100%. It's a bunch of like really small, sharp tools that do one thing well, that can be composed to do larger, more interesting things. And like, as it turns out, like they figured that out a while ago, and it continues to be like a really good solution. And so that's kind of the way that we're building that. And we're intending on building an experience kind of around that, where you can build these like pipelines that are executing those tools, but like under the covers. And we found this to be extremely valuable during some of our like more difficult production migrations. We need those failure loops to be as tight as possible, so that you're not waiting on timeouts. You can't have this like monolithic migration. You need to be able to verify like the steps that are happening. And when you need to go backwards because something breached your expectations, you need to be able to go backwards like one little step, not back to the beginning of the migration. So we've taken a lot of those lessons learned and incorporated them into Crane 2. So as a result, because it's this collection of tools, it's very flexible for its use. So you can kind of pick and choose what's useful for you. For example, like the Crane CLI has a command that says export. If all you care about is just discovering and exporting everything that's inside of one namespace, it will do that for you, and it will output that. Then it has a transform command that will allow you to layer on those changes that Jafar mentioned, to strip things out, really actually do arbitrary things, because it runs using a plugin mechanism. And so you can use it, you can choose not to use it. And so you'd be able to use Crane 2 and maybe the CLI. You can build solutions on top of it that you can then integrate with something like MTV, which is, by the way, also architected in exactly the same way that MTC is, so that it has an API surface that is represented by a series of CRs and CRDs. So you can automate that. You could build something that's calling into Crane 2, and then maybe it's creating CRs and watching status of those CRs to wait for MTV to migrate VMs. And then maybe you go do something else, maybe you move around to load balance or something like that. So that's kind of our philosophy, is that we're trying to build these like core building blocks. And then we're going to offer like an opinionated solution that uses those. We'll take sort of a position on how we think you should use those. But of course, you can get into the toolbox and start building your own solutions easily as well.
Nice.
That's cool.
Would that be to say that MTC2 would be the opinionated usage of all the tools in Crane too?
Yeah, most likely.
Yeah.
And we're trying to integrate with things like Tecton and Argo to build these pipelines that really, like, if you're familiar with Tecton, it's going to look like a pipeline.
I saw Jafar as soon as he said that.
Yeah. And so maybe those steps are running these Crane commands, and that you've got validations that are going to stop a pipeline in its tracks if you've validated something and it's failed that validation. So
I have another question.
Oh my gosh, so many questions.
Yeah. But that's a lighter one.
Yeah.
So will MTV2?
The bill is just getting higher, Jafar. I mean,
yeah.
You realize you're going to be invoiced for this, right?
Yeah, sure. Yeah, but this one is lighter. So will MTV2 be named VH1?
I'll need to run that by. I'll have to bring that one up. That's not the first time people really like the MTV name.
Awesome.
All right. That was it.
Beautiful. Thank you. Let's get to some point sharing over here real quick. I realized we're kind of already diverging from our normal schedule here to an extent. So this is the Level Up Hour. You've been watching it for a little while. Let me know if you can't see my screen. So about us. So Randy is here, but Randy does not have a Twitter. So that's fine. So I made him a short code just for well, apparently it's not sharing the right screen. That's fun. New share desktop 2. No, I was serious when I said that. Wow, Zoom is just being fun today. Thanks, Zoom. All right, there's points. Enough inception. So Randy has a LinkedIn, just red.ht/RR-LinkedIn. They'll take you to Randy's profile. Scott McBrien, who I said is off today, you can follow him on Twitter. Jafar is on Twitter as well. I am on Twitter. And we have our world famous Discord where you can check in with us at any given moment in time.
Feeling peer pressure.
Pressure. Small peer pressure. No big deal. But if you are curious, show notes from last time, I put those together. They are up there on the show notes page, as well as show notes from this episode are already done. And you can find those in the Level Up Our GitHub repo, which I just dropped in chat. But what you all really want to know is this: sweet internet points. Who's got what and what's got who. So if you want to participate in what we call sweet internet points, all you have to do is go to the form that's shown on screen here, and I'm going to drop links for everybody in chat. You too can get your sweet internet points, which at this point have no real value other than bragging rights, but we hope to have some real value to them in the near future. We keep saying that, and maybe that'll happen. But Narendev is clearly in the lead with NL Hackham right behind him, and then Noah Friction, followed by Conan Kudo, Bacon Fork, and Joe Fuzz. So if you want to see your name on this list, feel free to check the archive of shows and go back to get other codes to drop in to the form to get you more points. And I think that's the last slide. Yes, it is. So any other questions from the audience? Any other questions from Jafar or Randy or anybody at this point? Erica, did you feel like you covered everything?
Hopefully I didn't talk too much.
No, this was great. And like Jafar, I know this show is in good hands with Jafar, Randy, and Scott, because Jafar can just ask questions that are related to everything. So yeah, please check out the Konveyor community itself. Link drop there. And then when in doubt, please like, subscribe, and share as always. And coming up next on the channel, assuming there's no more questions or anything from the audience, I'll give you a few seconds to chime in. Coming up next on the channel today is Ask an OpenShift Admin with the one and only Andrew Sullivan. But we also have a special guest. My friend John Spinks will be coming on. We'll be talking about Red Hat insights for OpenShift. This is like having a highly technical person sitting in your data center saying, hey, something's broken over here. But you don't know that because this config mismatch is very unusual kind of thing. So it'll be interesting to see how that works in OpenShift. I know we've talked about it on the channel as far as RHEL goes, but in OpenShift clusters, that'll be a very interesting topic of discussion. So, Eric, do you feel like you got everything off your chest you needed to? MTC, MTV, NTA, VH1, BET, whatever. Yeah. All
Actually, let me share one other thing.
Oh, yeah.
If you are interested in MTC, okay, Red Hat does offer a course on migrating. So if you want to find that, if this is all something that speaks to you and you need to know about this, please look up DO326. That's the course code for our migrating applications course that we offer at Red Hat.
And you've got me Googling now. So hang on, let me find the link for that for everybody. DO326 is the number. Ooh, wow, that is actually used in a lot of different things. Okay. Randy, if you have a link to that.
Yeah, you got to include Red Hat with it. Otherwise,
yeah,
you never know what you might pull up.
Yeah, DigitalOcean, who knows? There we go. Red Hat Migration Lab. Ta-da, link in chat. And there you go. So yeah, you can get your training on. For all
the only other thing I'll mention too is that Konveyor as an organization is actually on the Kubernetes Slack instance. So if you want to actually reach like all the engineers are there that are working on this, you can talk to us every day. We're in there. So that's the Kubernetes Slack, and then it's like just pound Konveyor. You'll find us.
Yeah. Let me find the slack.kubernetes.io link real quick to drop in chat. And you can find them on the Konveyor channel. That is Konveyor with a K. And they'll be happy to help you out. I am also in that Slack, so feel free to ping me with anything. As always, you can reach me on Twitter at Chris Short, or if you have any questions or suggestions for future shows, feel free to email me short@redhat.com. And yeah, thanks everybody. We really appreciate y'all tuning in, and thank you, Randy, Jafar, and Eric.
Thank you, Chris. Thank you, Eric.
Yeah.
Do.
Thank you, guys, and see you soon.
Yeah, we'll see you soon, and check us out here at 11 a.m. Eastern, 1500 UTC for Ask an OpenShift Admin. That is an office hour. You don't have to just tune in for only the topic. You can ask whatever questions you want during that office hour. So feel free to jump on that, and we'll answer all your questions for you. If not, we'll find somebody that can. So thank y'all. Stay safe out there.
Thanks. Bye-bye.
Thank you.
See you.